people in Argentina.
Bueno, pues empezamos la primera sesión.
So we're starting with our first session of this second day of the seminar. And I have the pleasure of having 4 wonderful professionals that are going to be with us in the next block. They're going to do 3 presentations. The second one is by 2 engineers, Bisio and Daguerre from Argentina. And in this first session, as part of the seminar, as you know, we are putting on the table globally all the initiatives that are addressing important aspects such as recycling of our roads, both those that are made with concrete as the pavements that are asphalt. So I'm going to introduce the first presentation.
Presented by Naailah Mia. Naailah, she's a civil engineer. Currently, she works as a project manager for the northern region at the South African National Roads Agency, and she's going to speak us about the sustainable road solution using reclaiming asphalt. So, Naailah, it's your time, please.
Good day, everyone. I hope everyone can hear me well. So the presentation that I'll be doing is on a sustainable road rehabilitation solution on reclaimed asphalt on the Camps Bay Drive. It was a case study that was done in 2015. What I will, yes? Okay, sorry. Okay, is that better? Not. Okay. Is that better? Okay, perfect. All right, so the contents that I will be discussing today is the introduction, the background, key design aspects, key construction aspects, and the outcomes and lessons learned with regards to this project. This project was located on the Camps Bay Drive, situated in Camps Bay in the west South Africa. Major scenic route that links Cape Town and the CDB to Camps Bay and Hout Bay. It is then going to become a bus rapid system transport road, so there will be a few buses on this road. The city of Cape Town does have extensive stockpiles of reclaimed asphalt, and currently they're using this material for shoulders, which is poor use of high quality material. This would be now the first trial that the city will be using an off-site static mobile mixing BSM foam on a road. A background on this project: it was constructed in the beginning in 1848 to provide access over the Kloof Neck to Camps Bay. It was then converted to a tramway from Camps Bay to Kloof Neck, which was known as the finest tram ride in the world. In 1933, the tramway then was ceded to the city council and converted from a motor road to a motor road called the Camps Bay Drive. When they converted this from a tram road to a motor road, there was no attempt to alter the old tram route by straightening the curves. So as you'll see further down, there are a lot of curves that were substandard. It was originally constructed 6 meters wide, and it took 100 men and completed in a year. With this in mind, there was a substantial increase in traffic volumes since 1933. The traffic loading and the vehicle sizes resulted in the widening of this road. So here's a few pictures that you can see of the old tram road, and then when it was converted into a motorway, you can see the substandard curves that we had. The design traffic on this road, there wasn't any design traffic, so we did a 7-day count. The Kemps Bay Drive has very low heavy vehicle traffic volumes ranging from 3.1% to 2.4%. So this road was then designed for an ES3 to an ES10, which is about 2.28 MISA and 5.10 MISA for a 20-year design life. The geometric design, as I mentioned earlier, there is 16 of the 25 curves that were below the 60 kilometer standard, and 50 to 80% of this road then required widening due to the buses that will be using this road. So it was then concluded that we will widen this road by 1.4 meters. The pavement design. There was no as-built data for this pavement, which is normally common for the age of this pavement. The defects on the road included crocodile cracking associated with pumping, moderate rutting, shoving, and potholes. Generally, the defects were more severe downhill than they were uphill. The investigations that were done on this road, we had 9 test pits, about 6 test trenches, and 21 DCPs. From the test pits, we gathered the information that the asphalt surfacing right now is between 60 to 190 millimeter thick asphalt. The subbase was 60 millimeters to 120 millimeters penetration McAdam, so the largest stones. G7 selected in subgrade, and then 1 isolated area where the subgrade was a G10 material. The pavement design considered, there were 3 pavement designs, which was a 200 millimeter BSM option, a G2C4, and a... The BSM option was selected based on the reduced cost, the ability to apply traffic directly after construction. The employer also has a large variety of RA material available, and it would reduce the construction time. The pavement design for this BSM option, so the required RA for this project of 2 kilometers long was about 4,200 cubic meters. The testing of the RA stockpiles that we did do was formed part of the coarser side of the BSM foam envelope. So you can see from the picture on the right-hand side where the grading of the material was more on the coarser side. The cement, a cement and a lime was used, was 2 of the options for an active filler. However, after we had done some tests, we realized that the cement would be used as an active filler as it had a greater influence on the indirect test. Tensile stress, ITS. Testing was carried out on 2 available stockpiles of the material using 100% RA options with 2.1% net foam bitumen and 1% cement. From the 2 stockpiles, the tests indicated that the cohesion was 251 the kilopascal, the angle of friction was 43.1 degrees, and the retained cohesion was 63%. In stockpile 2, the cohesion was 215 kilopascals. The angle of friction was 45.4, and the retained cohesion was 81%. South Africa, we can see that in stockpile 1, the retained cohesion did not meet the standard, and in stockpile 2, the cohesion did not meet the standards that we require. So as part of the BSM design, in order to assess the impact that this would have by not meeting the specification, a sensitivity analysis was carried out on the pavement design using a deviated stress ratio, the DSR, and varying the stiffness, cohesion angle, angle of friction, and the traffic loading. So as you can see from the results on the right-hand side again, The DSR had a 30% for kilonewton, and the maximum DSR had a 39% for 120 kilonewton. Based on the low DSI values that we received or we seen, the decision was made to then continue with 100% RA mix, as the risk was considered to be very low. So the construction and how the construction was done is we box cut the road widening, the road 1.4 meters, milled off the asphalt to the stockpile, removed the macadam, and then paved the BSM in 202 by 100 millimeter layers. And then on top of that, we had an AE2 binder asphalt of 50 millimeters. The outcomes and lessons learned with regards to this project. The BSM mix is very field dependent, so the moisture content had to be, we needed to pay close attention to the moisture content, and you needed somebody on site that had some experience when it comes to the BSM to determine whether the moisture content was correct. Low fines, so due to the fact that this was more on the coarse side of the grading envelope, we had low fines. We looked at crushing or its screening, so to consider that. Mixing temperatures, that was extremely important, especially in Cape Town, as Cape Town has a winter rainfall and the temperatures in winter get really low. So the material temperature had to be being looked at well so that we could get the right ITS values. We also did do this project during the winter months because there's a lot of tourists that come during summer months, and the client did not want the road to be closed during that time. So paying attention to the temperature was important. After this project, we did learn, though, however, that maybe in Cape Town, for example, we should look at an embargo period where BSM should not be paved during certain temperatures or at certain times of the year. In conclusion, using recycled asphalt in road construction can reduce the use of virgin aggregates, reduce emissions from transport and asphalt heating, and creates a cycle of material that can be recycled. The volume of use when asphalt surfacing or bases, you can only use approximately 20 to 40%, which is South Africa's standards. But if you use it in a BSM, which is your lower layers, you can get up to 90 to 100% use of recycled asphalt in roads. More cost-effective and sustainable solution for the future in the world where we are depleting aggregate resources. Thank you for your attention.
Thank you very much, Naailah, for your fantastic presentation about the roads in South Africa. I don't know if you know that, curiously, a day like today, 21st of September, but the year 1756, born John Loudon Macadam. You refer Macadam. So a day similar than today, but in the year of 1756 was born John Loudon Macadam. Thank you very much for your fantastic presentation. Dejaremos el turno de las preguntas y de las cuestiones.
So, questions and answers will be for the end of the block after all the presentations. And now I will give the floor to the Argentine engineers, Alejandro Bisio and Lisandro Daguerre. Alejandro is a road engineer. He has been working in private and public institutions, and he is specialized in design, construction, and quality control projects. Lisandro is civil construction engineer. He has a PhD from the Polytechnic University from Spain. He's specialized in flexible pavements and in the study and design of asphalt mixtures and application of new technologies. I'm sure that given their expertise, they are going to give us a great presentation on the recycling and use of asphalt mixture, and they are going to show a case study, the development of Bun Ayre Highway. You have the floor. Good morning. Good morning, everybody, and thank you for the presentation. And I would like to thank PIARC for the opportunity to share this case study, and it's going to be, as we said yesterday, published. And I would like also to thank, on behalf of Maria, the organizers of this event, and because they have given us all the tools to be able to make this presentation. I would also like to thank our audience, because you have given up your time to listen to us this presentation. Also, it means we need to thank Camino del Bun Ayre, the owner of the case study we are going to share with you, Coarco, the constructing company, and the La Plata University Engineer Department that conducted quality control, and that have made all data available to us to make the presentation today on the rehabilitation of Bun Ayre Highway. As an introduction, the Bun Ayre Highway, it has 23 kilometers long, approximately. It has 3 lanes per way, and it connects the main access to the city of Buenos Aires, the northern access and the southern access. It has an AADT of 100,000 vehicles per day and 25% heavy vehicles. And within this group of heavy vehicles, there's approximately 15,000 waste tons being transported every day, because the waste treatment plants from Buenos Aires is close to the highway. The structural package of this highway was from the 80s, dated from the 80s, and it was an asphalt layer of 6 centimeters over sand and asphalt, as you can see there on the graph, and this was over lime soil. When we started with the construction works, the structure was worn out in general, and there was great rooting in the slow lane and some cracking. And this was the result of rigidity in the asphalt layer, and also structural insufficiency for the traffic that was going through this highway. So the decision was made to start rehabilitation. The project was conducted by the University of La Plata, and given the structural status and the material status, we decided on a project for 10 years of life cycle that included the laying of 400,000 tons of asphalt mixture. So the solution for the speed lane, for the fast lane, was different from the solution for the 2 slower lanes. So let's focus on these 2 slow lanes, slow speed lanes, because in this these structures include the recycled material. The two slow speed lane had overlay, a surface of SMA 19 millimeters, a base layer, dense asphalt with modified asphalts of 19 centimeters, and this was over the 18 centimeters sub-base, 7.1 inches, and this had the RIP, the recovered asphalt, that came from the asphalt layer that we saw before in the pictures. These 18 centimeters are now the sub-base of the slow speed lanes, and this is going to be the focus of our rest of our presentation. RIP, the existent asphalt layer that was 6 centimeters, when it was milled, was turned into RIP that was reused in the 18 centimeter sub-base that we saw in the previous slide. If we come to the design stage, we may say that apart from the usual components of asphalt layer, we had a new supply here that was the RIP that came from the previous layer. And in this stage, when we had to have the work formula, we decided that the performance of the asphalt mixture that contained the RIP should have the same behavior and the same performance of a same nature asphalt layer. I mean the same granular and the same degree of conventional binder, but made up from virgin materials. So this was the premise of the development of the work formula. This scheme, this flowchart, shows all the solutions we needed to get for the work formula. We had the RAP that shows rock, and we incorporated virgin aggregated to strong the granular structure, and the asphalt binder coming from the RIP was added a virgin asphalt binder, and as a result we had a resulting asphalt binder. And combining the two and the interaction of the two resulted in what we called the volume of rock aggregate. So if we tried to get the same service on the granular structure made up of these two materials, and we have the same requirements of virgin mixture, and for the resulting asphalt, we also consider that we need to have the same performance of a virgin binder. We may infer, given these two premises, that the resulting asphalt mixture is going to be at least will have the same performance as the virgin asphalt mixture. So once we had the granular structure and the resulting asphalt binding, the optimal mixture of the asphalt was designed based on volumetric design. And once we got that, we started with the verification and testing stage. If we start, let's try to give some details on the design project, but this is a final result of the design process. So the recycling rate was 20%. This 20% RIP provided 19% of granular structure. 76% of the granular structure came from the virgin aggregates, 0.9% of the asphalt came from the binder containing wrap, and 3.9%, 3.7 in fact, it's not 3.9, but 3.7 came from the addition of a virgin asphalt binder. As to the RIP features, the mean optimal asphalt content throughout the works was approximately 4.5%, and the status of the RIP asphalt as regards its behavior had 60 degrees viscosity, and so the mean value, considering natural fluctuations because it's a recycled material, was 42,000 decipascals per second. So, for the asphalt binder, we used washing tested with methylene chloride, and the binder came from a controlled distillation through steam, and once we got the asphalt binder, we started with the radiological status in this lab at 60 degrees. Why viscosity should be 60 degrees? That was the reference parameter we adopted, and it's basically because in Argentina, the asphalt classification is based on 60 degrees by viscosity. The Argentine regulation divides conventional asphalts in 5 degrees, and in this case, the asphalt design is the one that should be used in the asphalt mixture if the asphalt mixture should have been virgin. This CA30 is 2,400 decipascals per second as regards viscosity, and the regulation says that this viscosity that is natural as it comes from the provider, from the supplier, should be increased 3.5 times as from the testing at the time of preparing, transport, or laying the mixture, and that was how we did the testing of the asphalt binder resulting from this mixture. And so this resulting asphalt binder that came from the already recycled asphalt mixture, and the viscosity should not exceed 12,600 decipascals per second. Where does this value comes from multiplying 3,600, which is the maximum value for CA30, times 3.5, what is the maximum increase allowed. As to the asphalt mixture, 0.9% came from the RIP, and 3.5% came from the virgin asphalt binder. From the percentage point of view, if we focus only in the asphalt binder system, 19% was the asphalt coming from RIP and 81% from the virgin asphalt. Mean viscosity 60 grades was in 10,600 decipascals per second. In order to have this viscosity in the resulting asphalt binder, it was not necessary to use a lower grade asphalt binder. We just used a CA30 as the virgin binder. In certain specific cases, in order not to exceed this limit viscosity value, we used one or two lower grade binders, maybe CA20 or 10, but in general we used the same grade of virgin binder. As to the granular structure, 76% of the virgin asphalt came from 2 coarse aggregates, 1 fraction of fine aggregate, and 1.2% lime because of durability issues. once we already had the granular structure coming from the aggregate blend and the asphalt binder, we fix as design criterion the asphalt content with 4% empty or holes. So then we tested mechanically this material against wetness damage and permanent deformation through the wheel tracking test. Once we had our mixture designed, we went to just making or constructing the mixture. But first, we have a previous stage that is very important in order to be successful in the recycling is RIP management. RIP management is all the tasks to reduce the natural variability of the RIP because it's a recycled material. This means that we need to divide RIP by origin or size, since this it was just we did not do an origin division because it came everything from the same place, but only on stretches where patching was done. But what we did was division per size. We had a coarse and a fine fraction of the wrap, and also we had the possibility of having atmospheric coverage of the RIP given the weather conditions. Here we have an bird view photo of the plant used for this asphalt mixture, one 300 tons an hour plant and the other batch plant of 150 tons per hour. To the left of the photo, you can see the structure for the two different wrap factions, the coarse and the fines, that are critical as regards wetness. Here you can see the continuous flow plant. On the left, you can see the feeding system, two hoppers for each of the different wrap fractions, and a conveyor belt that sends the material to the drying drum with no contact with the flame, and then we have the mixture of the wrap with the virgin aggregate and the filler. Then the material is sent to the upper part where the mixture is there and the virgin asphalt component is added. The other is a batch plant where here wrap was added to the mixture and entered at atmospheric temperature. So if the objective was to keep temperature constant, a difference between the two processes has to do with the temperature of virgin aggregates. In the case of batch plants, the temperature of virgin aggregates was higher in order to compensate that 20% wrap coming at room temperature, at ambient temperature. But we didn't find out any significant difference up to the rheologic property of the components of the asphalt mixture when they were produced by the two different methods. As to the compacting, when this layer was laid as a subbase, 18 centimeters subbase, though this has nothing to do with recycling, but sometimes we think that this type of mixture is more complex. I can tell you that you can see here a photo of the works. We had the fast speed lane, and then the two slower speed lane. Once we had the mixture, we milled the overlay, then we had a 18 centimeters trench, and the mixed asphalt layer was laid in just one single laying movement, only one operation, and those 18 centimeters were compacted with two metallic compactors, two different compactors. You can see here the photos. We had that type of box that favored all the conditions in order to achieve the compacting grade. In some enlargements, we laid unconfined 18 centimeters, but that was just in certain specific stretches. And then we built the cooling curves. We checked them, especially for the compacting pattern design, in order to fix this compacting process, and this formula was used during the whole job. You can see a photo of the 18 centimeter samples cores, and they were used to evaluate the homogeneity of these cores, and this was successfully verified, and there were no differences as to the empty content and the different cores. And in the upper part, there are better compacting percentages that in the lower layer, but it's something to be expected. But here we can see certain results, mechanical and results. If we did the steel test, we found out that there were no significant differences in the stiffness value between the upper and lower part of these 18 centimeters, having mean stiffness values of 4,500 to 5,000 megapascals. And this is the look and feel of the job at the end of the construction work, and now it has been going for 9 years, and these are photos of the current status at September 2021, where after 9 years of service there are maximum levels of 3 millimeters rutting. And we have taken some course during this month, September 2021, to evaluate the rheological properties of the asphalt components at 60 grades and 60 degrees, and
de los cuales habíamos obtenido
so I think that it's a quite good situation given the results we have obtained. So while it is quite a good situation, the results have really surprised us, and they are quite good results. As conclusion, I would like to thank you for listening to my presentation, and we can say that for these recycling rates, while originally we to use 50% or more recycling rates, in this case the trend was to use less ambitious recycling rate, 20 or 30%, but they are nonetheless important from the environmental point of view and economic point of view. And by working with these recycling rates, the job can be easily done with the resources available. Thank you very much, Curro, for the time, and then we are available for the Q&A session if there's any question. Thank you very much.
Alejandro, pues fantástica presentación, creo que muy completa, donde has abordado toda la tecnología desde muy diferentes puntos.
Thank you very much for that complete presentation. And I want to remind our 355 participants that are connected with us that the Argentine Association has prepared this wonderful platform, and you can enter your questions in the Q&A box at the bottom of your screen so that I can see the questions and then ask our presenters. I'm saying this for whoever is using the chat so that you can ask questions or make comments, but for specifically for the questions, use that tool.
100 participants in this seminar at this moment. Please employ in the fantastic tool, digital tool that the Argentina Association prepared for us to stay all together here. In the corner, on the right, in further right, you can send your questions. Sin Custody from Ireland, don't employ, please, the chat to share your question to the participants of this seminar. So now began with the last participant in this session. His name is Mr. Aurstad. He is Joralf Aurstad. He came from Norway, and he is a senior principal engineer at Norwegian Public Roads. Belongs to administration with more than 35 years of experience in road technology, mainly in topics of design and maintenance for roads and asphalt pavements. He's a very important person in Norway, and we've got the pleasure to that he stay with us. He's going to speak us about organization asphalt recycling and about the information center for recycling of asphalt in the country of Norway. Mr. Aurstad, it's your turn now. Thank you very much.
Thank you very much. No, I'm not actually seeing my presentation myself, but I can share.
Esperamos un segundito mientras se solucionan estos pequeños problemas que están perfectamente solucionados.
Let's give him a second to solve the technical questions.
I'm doing my best.
That's perfect now.
There, can you see me? Well, thank you so much, and hello to you all. And thank you for inviting me to your seminar. It's a really big honor for me to be here. And in this presentation, I will try to give you a picture on how we have worked with asphalt recycling in my country, in Norway. First, where is Norway? Some of you may ask. Norway is situated in the upper left corner of Europe, as you can see here, facing the western winds and the cold Arctic Ocean, but luckily also the warmer Atlantic Gulf Stream from Mexico. So we have a rapidly changing climate, often 4 seasons in one day, as we like to say. As everywhere else, the road users expect optimal driving conditions at any times. One special thing and one special challenge in Scandinavia is our use of studded tires to better ensure traffic flow and safe driving conditions during the winter season. But these studded tires also has a backside, appearing when the snow and ice is melting in the spring. Here you can clearly see the wearing effects from studded tires on bare asphalt. Where we have safety in the winter, we can have problems in the summer. During or after rainfalls, when these ruts are filled with water, they may cause risk of aquaplaning and problems with splash and spray. We also see an increased problem in the cities due to fine dust particles coming from this severe asphalt wear, and this has actually become a serious health issue in my country. We are constantly working on reducing the studded tire wear by optimal mix design and use of high-quality aggregates. In some areas, also now combined with studded tire limitations. So, often you will see these machines on our main roads in the springtime, milling off and planing the traffic lanes to eliminate the ruts after the winter season. And every year, this milling process generates large quantities of RAP materials and reclaimed asphalt. In general, the Nordic countries have good access to high-quality road building materials. Norway is a stone and aggregate exporting country with a substantial quarry industry. But we also now see that our sources are limited and must be controlled. Therefore, reclaimed asphalt from milled or excavated pavements must be handled as valuable materials. Every year, more than 1 million tons of reclaimed asphalt materials are generated from milling and excavating operations on Norwegian roads and streets. It has been a challenge to utilize these materials properly in our long and narrow country cleaved by fjords and mountains. High taxes on waste can be a carrot for increased recycling. But it can also be an excuse for emptying the lorry where it should not be emptied. And we have seen many wild fills, so to speak, in the forest or elsewhere, as seen on this slide. The road construction industry can be a rather conservative business in our country, because they are so used to high-quality, new, virgin materials. And as road owners, we must also admit that our road construction manuals and specifications also have been based on traditional experience. Here, we all really need to change the way of thinking. So, 20 years ago, the idea appeared. What if we work together, industry and road owners, and don't sit waiting for the government and the authorities to come up with more legislations and restrictions? In 2001, 2 different and very important initiatives were launched. We got our first National Action Plan for Construction and Demolition Waste, and, more specifically, the Info Center for Recycling of Asphalt was established. The Norwegian Info Center for Recycling of Asphalt was established as a voluntary association between the road owners and the asphalt producers. The primary objective was to ease recycling and also to avoid any possible unnecessary environmental taxations on production and use of asphalt materials. An overall target value was set to 80% recycling reclaimed aggregates into new road applications. This figure was actually rather ambitious compared to the recycling objective set by the European Union on construction waste, which was to reach 70% recycling by the year 2020. The InfoCenter is financed by collecting an earmarked green fee on bitumen, sold to be used in the road sector in Norway. The green fee is currently 7 Norwegian krones, about $0.8 per ton bitumen. It can be mentioned that the total bitumen volume in our country for asphalt payments is quite constant. It is about 350,000 tons per year. One key factor for succeeding with recycling in our long-stretched country is that dedicated storage sites for RAP have been established spread out the whole Norway. The InfoCenter is constantly updating a national register of these sites, as shown on this map. Currently, there are about 250 of them. And wherever a construction, milling, or excavation job takes place in Norway, the contractor is obliged to bring the reclaimed asphalt materials to one of these sites. The sites all report to the InfoCenter on the material streams going in and out their gate, what is received versus what is used or exported. And to ensure that these collected materials really will be recycled, the legislation allows for only 3 years of temporary storage of the RAP materials. In this way, recycling projects can be properly planned in the same area, and the materials can be utilized in their best way. Especially in rural areas, this is important. And another important matter is that samples are taken regularly for material control. From a health and environmental point of view, there is a special focus on tar content. Fortunately, this is very seldom found in Norwegian asphalt, since we haven't used tar since the early 1960s. Here, the InfoCenter's main activities are briefly summarized. I have already touched into most of the points. But this year, it is 20 years since the establishment of the InfoCenter for recycling. It is time to evaluate. To what extent have we succeeded? Here is a table from last year's annual report from the InfoCenter, summarizing the data from 2016 to 2020. Have we reached the overall objective? We can see that we are far above the targeted 80% that we set 20 years ago. Actually, we are above 100%, showing that we are now also eating from old stockpiles from before the InfoCenter was established. Even though we managed to utilize in road applications all reclaimed asphalt materials that are generated each year, we must admit that we are not the best in class putting them into new asphalt layers. As you can see in green color here, most of the volumes still go to unbound applications. That can be base and sub-base courses, temporary road surfacings, road shoulders, and so on. One reason is that we have very high quality demands on asphalt pavement aggregates, due to our winter conditions and our use of studded tires, as I showed in the introduction. But we have higher ambitions on this, and we are sure that we also will be able to increase substantially the amounts going into hot mix applications. Just to sum up, establishing the Info Center for Recycling has been crucial for putting asphalt recycling into system in Norway. We are also constantly looking for improving our contracts, again, together with the industry. For instance, by trying out different bonus systems. And we have now also taken environment and carbon footprint in as a procurement criteria, together with costs. And here, as you know, use of recycled asphalt immediately gives a substantial effect. The fact that we also have a common European standard for recycled aggregates is also an important incentive. But again, both industry and customers in Norway are used to cheap and abundant high-quality virgin materials. Therefore, for promoting recycled materials, information and more information again is very important. This is an ongoing process. The recycling wheel does not spin by itself. And here, the Info Center plays a leading role. Here is a picture from one of the research projects carried out by the Info Center. On this highway, we have looked at using reclaimed asphalt aggregates into new polymer-modified pavements on high-volume roads. More details on this project can be found in another separate case study in the coming PIARC report. For those of you who are interested, can find more information there. The Info Center's board has often very heavy discussions, but the fact that we are sitting together there, road owners and the industry, has without any doubt been a successful factor for promoting asphalt recycling in Norway. Finally, our Norwegian roads, with and without recycled materials, end up here, up on the North Cape. You are all welcome to take a visit. Thank you for your attention.
Thank you very much for your fantastic presentation, Mr. Aurstad, and to share with all of us the experience of Norway in recycling materials in the road. Thank you very much, my friend. Bien, hemos acabado el turno de las intervenciones.
With that, we finish the presentations in the morning, and we have followed the schedule that we have, that our friends from the Road Association in Argentina prepared. And actually, we have 2 extra minutes. So with that, we're going to open the Q&A so that we share questions that many of you entered in the Q&A box. When the questions are asked in English, I'm going to ask them in English, and if they are asked in Spanish, I'm going to say in Spanish. And we are going to hear the interpreters, who are doing a fantastic job. They are going to do simultaneous interpreting of the questions in whatever language is used, as they are doing with their presentations. Thank you. And with that, we are going to start.
In the chat, it's not in the question box. And it's for you, Naailah. It came from Sin Cassidy from Ireland. And he or she, sorry, I don't know if Sin is a male or female name. And he asked for the ITS testing, what curing regime did you use for the BSM specimens? You know? Do you need that I repeat the question? Naila?
So we use the ITS is the indirect tensile stress. We have a machine. The curing stays were. Can I? Do they want to know what was the curing days that we used? What was the question? Sorry. Can you repeat the question for me?
Yes, it's for you. I repeat the question, okay? Thank you, Naila, for the ITS testing. What curing regime did you use for the SM? Sorry, specimens?
Well, we use tests were carried out between 170 and 180 degrees Celsius for that.
Perfect. Okay, thank you very much. Las siguientes preguntas.
The following questions are for Alejandro about the recycling case study in Argentina. There are several, and I would please ask you to be as quick as possible in answering the questions. We have 20 minutes, but please be as brief as possible in answering the questions. Sofia Figueroa asks what type of binders did you use, and did you use modifiers? The binder for that layer for the focus of the case study was a conventional binder. It had no modifiers added, and it was not required for the 20% recycle rate that we use. Just conventional asphalt binder coming directly from the supplier. Carlos Fonseca also asks, after congratulating you for your presentation, is the resulting asphalt cement, what kind of temperature was used to have the moisture, the natural moisture or wetness of the asphalt brought any issue or any problem? In general, if we work with RIP with no coverage, if it was not covered or protected, we may have some issues or some problems in the production of the asphalt mixture, because water coming when we have a batch plant, the water coming is at atmospheric pressure, and of course there's water when it comes to the mixer where we have 170 degrees. There's instant vapor generation or steam generation, and so this complicates the durability of the equipment. That's why we decided to have for amount for 2 days of production stored. Ana Sofia Figueroa also asks what agent tests was done to the RIP. To agent state, none. What we did was rheological behavior tests or assays. The reference was 60 degrees viscosity, because that's the main test we use in Argentina to classify conventional asphalts. But additionally, as they have the equipment available, we also did G-star or mismatch angle, deviation angle, in order to have information about what type and what amount of virgin binder we should add. Jose Martinez asks if you wanted to have the same behavior in the asphalt for a typical 10-year life cycle, which were the new loads considered and the volume of traffic. So what would happen after those 10 years? Originally, it was designed for a 10-year life cycle, and we estimated 45 million equivalent vehicles for the slow speed lane. And it's clear that the structure placed on a lower subbase is not seen as affected as regards the aging of the bitumen, but if we added smaller rock aggregates and that thickness, we were able to extend the life cycle, and as of today, the possibility of once again recycling that material is there. And by measuring the aging and the viscosity, we are approximately at 12,000 decipascals. And this means that this material could be recycled and reused again. And today there are no deformations in the whole structure, so there's no need to do any intervention in principle. So the macrotexture is preserved, and at least it has a couple of years of life cycles with no need for interventions so far. Thank you very much for the question, for the answer. Have you had in mind, when designing the project, the reuse of the new resulting surface? I think that I understand the question, meaning that this would be decision made later on in the design phase. It's what I have already answered. The company, the CMC company, is a company of waste management, so they already think about recycling material. The two main layers are have a polymer addition, and the conventional bitumen and conventional asphalt have certain characteristics, and since they are not aged, they could be reused at a certain point in time. So Miguel Favaloro also asks, did you measure deflection before and after the overlay? Yes. We did the following way. We used the following way, taking into account the structural design we had. We considered deflections measured through the falling grade test.
I need to translate because this question is from Nilda Stefania Fretes. Naailah, she's asking you, in the case of the highway, the mix of the original mix of RAP was with bitumen conventional or modified, or with modified bitumen, and if you are employ regenerators for the final asphalt, and which kind of plants you employ to produce the mixes. Do you understand the question? The three questions in one?
So we use the KMA Beltrafen off-site static mobile plant for the preparation of it. And with regards to the first question, which was, I forgot what was the first question.
Yes, if you employ modified bitumen, and if you employ regenerators for the final asphalt.
So we used a modified bitumen, a modified bitumen for it, but we didn't use any. It was a modified bitumen that we used.
That's perfect. Thank you very much. At this moment, la siguiente pregunta.
Next question. Well, we go back to Argentina from Ana Maria. And the question is, to use RIP in the hard shoulders? I acknowledge that I don't know what the word for hard shoulder in Argentinian Spanish. I don't know it, but I'm sure that you know what I mean. Yes, hard shoulders. The hard shoulders of our road. I would say RIP has a very important added value with the bituminous binder, and in my opinion, though we use cold mixtures, the possibility of using RIP and hot mixes from the third and economic point of view, it's more advantageous that mixturing it with soils and doing cold laying. We take advantage of the economic benefit of using it in hot mixtures, but nonetheless, it can be used in cold mixtures.
Okay, the next question is for Mr. Aurstad. Joralf, the next question is for you. And Mike Vargas Martinez asks you if in Norway is common the use of the hard warm mixes. And if you employ the hard warm mixes, which kind of lians, of asphalt, you use and employ in the production of this kind of mixes? Understand?
Yeah, do you hear me? The question was regarding warm mix asphalt?
Half warm mix. And I think she employed a tibios asfalto that is under 100 degrees temperature. Correct me if I'm not okay. Lisandro and Alejandro, cuando emplean el concepto.
When we say half warm, we are talking about mixtures below 100 degrees. Yes? Yes, it's okay.
Hard warm, correctly.
Yeah,
not you employ in our... Good.
No, not very much. It was used to some degree for 25, 30 years ago, but not very much no longer. But the warm asphalt mix concept is taking increasingly a bigger and bigger portion of the total market. But half warm, we don't use that very much any longer, because we have got more or less the same price for, so to speak, more higher quality payments.
Perfect. Thank you very much. Querido amigo Vargas.
Thank you very much, Mike Vargas. I can tell you that tomorrow I'm going to make a specific presentation on the Spanish experience by using half-warm asphalt or temperate mixtures by using the 100% configuration of the mixture. If you are interested in this issue, I invite you tomorrow to watch my presentation. Let's go to the next question.
Again, a question for you, Joralf.
Another question for you, Joralf. Ana Sofia Figueroa asks that she will...
Working on the same way with universities in Norway. I think she's asking for you if there is a very good relationship between the university, the constructor, and the public administration. I repeat the question. I would like to know how your projects are working on the same way with the universities in Norway.
Well, actually, myself, I have some 20 plus years experience from university and research myself. So it's a very good cooperation between both the industry and the public road administration in particular with the universities. So we exchange laboratory services, and of course we also contribute to from our side, from the road administration side, we support both from bachelor, master, and PhD students, and inviting them into our projects and try to work as good as possible together. Yes, and we are also involved together in international European projects, for instance.
Perfect. Very, very agree with your opinion. The next is for you again. It came from Amy Meina. Sorry about your names, assistants. And he or she, sorry, was interested in knowing what is the maximum tax percentage of RAP allowed in surface mixes and in binder mixes, you know?
Yeah, it depends a little bit upon type of mix, because as I said, we have been quite restrictive against the wearing course, the top layer, because of our high quality demands on the aggregate. So, for instance, SMA payments, we have only allowed 10% RAP in those, but for binder courses, that was also the question. Then we allow up to 40% on the high volume roads. But of course, also it is possible to come up with suggest solutions that can give even higher percentages of RAP. But we have been quite restrictive regarding the percentage in our top layers. We are hoping that we are doing some research. I showed in one slide an example that we are also investigating, trying to increase the percentage of RAP also in bearing courses through following up project in field, also on high volume roads. And we are also using very much polymer modified binders in our top layers, and it has been a concern, given the fact that polymer modified pavement are so more expensive than ordinary bitumen, that if we are not very careful and know what we are doing by putting more RAP into it, there has been some worries that the costs of the PMB, the polymer modified, could be some kind of destroyed and eaten up by negative effect of putting RAP into it. But these thoughts are now decreasing, I think. So we are also going into higher percentages also with the RAP also in our most highest quality payments.
Very, very, very good. Okay, estamos a 2 minutos.
Okay, we are 2 minutes away from the closing time of our panel. We have some questions still, but before closing, I would like to ask the organization whether, since we have a networking space, we can make some of the questions we still have, or we need to close immediately. Please, can't you tell me whether we can make some other questions? Do we have time for more questions? Okay.
Going to confirm. Me encanta que haya muchas preguntas.
Really, it's very good we have had many questions. This has been a very dynamic panel. We had lots of information shared, and would like to see whether we can have some more minutes for some of the questions that we have received. Okay, we have. The organizers have told me that we have 5 more minutes to make questions. So, please be as brief as possible to answer those questions. Our next question by Emiliano Dottori is a general question for everybody. Do you have any experience in the use of RAP in superficial treatments in bitumen slurry or slurry seals or chip seals? Do you have an experience with slurry seals or chip seals? Do you have an experience in the use of these techniques that also include the use of bitumen emulsions? I don't have experience. I don't have personal experience, but in the case of treatment, it would be very important to characterize the materials, because the size of the particle has a lot of influence in these treatments. The shape, and if you have flat particles, you are going to have some issues. So there are certain technological barriers. I don't have personal experience, but it's something that I would study or I pay attention. I had some experience in Spain with that, but as you said, this requires very careful treatment and a good classification of the material you are going to use as a whole or in part. Do you have any experience? Any one of you have any experience on that?
RA into different size?
Well, normally we don't split that in different sizes, but we have requirements on the distribution curve for the materials to be added. But it is the final. We have the final requirements are set on the mix that the final mix. There we have the specifications. So it's up to the contractor actually to add the recycled aggregates in a way that it fits with the overall final requirements of the asphalt mix.
Perfect. The last question for you, and we are going to finish here, Joralf. How many times do you normally recycle the same asphalt in Norway? Do you have any restriction on multiply recycling? Very, very interesting question from Salt for us. Very interesting.
Yeah.
Very good.
Salt is always asking tricky questions. So, well, we don't have that. Not very much experiences with multiple recycling, but we have done actually the last, I think 2 years ago, we are conducted a field project where we tried actually to age and recycle and age and recycle and age and recycle again in the 4 times to try to get an impression on that, and we didn't see any tremendous drop, at least after 3-4 of these field trials. We milled off and when we mixed it and laid it out again, and well, it was only short-term aging. We cannot wait 10 years for each period of field aging, of course. But we don't see any problems yet, and I guess we have recycled to three times, perhaps, for the most.
Very
But
good.
again, we are not the best in class regarding high percentages. So I would guess that this is a question that is highly relevant for those countries who are putting higher percentages than we do into their mixes.
Thank you very much. Así pues, finalizamos el turno de intervenciones aquí.
Well, thank you very much. I think that we have come to an end of this panel, and I always like to close my panels by asking just for a title for all the... I will ask all my panel members just to give me a headline. Just give me a headline as regards recycling and reclaiming and reuse. Just a headline. 10 seconds. A headline about recycling. What do you think about recycling?
A titular for the final sentence for the use of recycling in asphalt, please.
Can you repeat that? I apologize.
Tan?
No, can you say?
Sí.
This session giving us a sentence, a titular, like a tweet, that your opinion of the importance about recycling in roads.
Recycling is one of those things that we need to do. I mean, we're running out of natural aggregates, virgin aggregates, so the more we can recycle, the better it would be for us.
Perfect. Alejandro, tu titular para cerrar.
Que el reciclado
So recycling, at least in our region, is seen as the future, but in fact it is here, and it has come to stay, and we will coexist with it for many years. More than an alternative, I think it is an obligation. It has come to stay, and it's an obligation. And not lose the possibility of use it appropriately.
Titular, your sentence to close this session, please.
Well, our virgin materials are limited, and we all have a responsibility to use what nature have given us as the best way.
Excellent. Bien, son las 15:36.
It's 3:37 p.m. in Spain, 5 hours backwards in Argentina. So I would like to thank our presenters. Your presentations have been excellent. I would like to thank 333 members of the audience who have joined us for these presentations. I would like to thank the Argentine Road Association for the great organization of this seminar. And of course, I would like to thank PIARC, the World Road Association, for connecting all of us, for sharing, in order to share experience of these important issues such as recycling, reclaiming, and reuse of materials in road construction. And I remind you that you will have some networking time before the next panel starts. We are not longer traveling, so but now we nonetheless have the opportunity of connecting with colleagues from other countries. In the box at the bottom left of the screen, you have the networking icon, and you will be able to enter the networking rooms in your language. Thank you very much, and we will come back in half an hour. Thank you very much.
So that we can organize them for the Q&A session at the end. We will start then with the first presentation, which is going to be by Pablo Morano and Omar Appolon, and they're going to present about foam recycling case study in the province of Buenos Aires. Pablo Morano is a civil engineer specializing in constructions. He has worked in the province of Buenos Aires Road Committee, and Omar Appolon is a chemical engineer whose career has taken place in the same entity as the head of lab and special mixes for asphalts. So, Pablo, Omar, you have the floor. Hello, good afternoon. We are going to show the presentation that we're going to do. And we have been working on the study of these materials for structural layers for 20 years. And among these materials that we have studied is RAP, and in the first stage we're going to apply it to granular stabilization for foamed asphalts. These experiences talk about 3 case studies where we started with lab studies through a simulator for foamed asphalt, and then there was an experimental trial, and after that we used this as the structural layer, as a subbase in or subbase in an actual road. So in these 2 decades we have used many substandard materials or not standard materials, and among them foamed asphalts. The RIP production is abundant, so we try to use it as best possible, knowing the potential of that material and the environmental damages that we sometimes cause when we use virgin material. So the idea here is to take advantage of this material, of this reused material, which was used at 100%. Here we have the province of Buenos Aires. We have more than 10,000 kilometers of paved roads, and we have different possibilities of use. First, as I said, we started with lab work and lab tests. As we know, foamed asphalt stabilization has 2 aspects: the expansion ratio, which is the relationship between the volume of the foam and the volume of the sedimented asphalt. This gives you an idea of workability of the foam material, and we will always try to come as close as possible to optimum ratio, which is the expansion ratio and the useful life of the foam, which depends on the time this foamed asphalt to reduce its volume to half. The longer that, or the bigger that number is, the more time you have to use it in the mixes. As we can see in the graph below, this foamed asphalt is a process of hot asphalt with pressured water injection that expands the micro bubbles of water that produces the foamed asphalt, and this material is going to be the binder for stabilization. The first thing was to study RAP that was aged, and it worked as inert material, as recovered material to be used in asphalt mixes. We can see the granulometric numbers. It's quite coarse, and then we have the granulometric curve at the bottom to do granular stabilization for this type of material. So 100% of RIP was corrected with stone fines commercial lime and soil from the base. We started developing types of mixes, and we had 3 curves that, so that we could define which one we were going to use. In the first one, as you can see, we had 77% of RAP. It was corrected with 20% of sand and 3% of lime, commercial lime. In the second one, we had 63% of RAP, crushing sands were 35%, and the percentage of commercial lime was only 2% to act as a filter. And in curve number 3, it was intermediate. It was 68% of RAP, the crushing sand 0.6 was 20%, 10% was soil, and 2% was commercial lime. So what you see here is that both sample 1 and 2 did not have added soil, and in sample number 3 we had added soil. These are the curves that we can see from the 3 types of samples, where we can see that sample number 3 is the one with the most added fines that were added so that the mix of foam, asphalt, and fines was the perfect one to get the cohesion that we were looking for and the binding that we were looking for. We did the tests, and here we have the maximum densities for 5 layers and 56 impacts, and we have 190.75, 2.011, and 2020 regarding density. Then we have the moisture, and we evaluated 3 types of foamed asphalt. First one was 1.5, 2.5, and 3.5% respectively. The second one was the values that you have in the middle. And in the third one, we used 1.3, 2%, 2.6, and 3.2% of asphalt. With the simulator, in order to get the foam that we were looking for, the air pressure in the simulator was 4.5 bars, and the water pressure injection was 5.0 bars. The percentage of water for the foam was 1.5%, and then the molding of the cores was using a Marshall equipment, and we did resistance testing and diameter compression with cured cores using a resilience index that was at least 75%. Of the 3 samples or cores that we used for the tests, the one that gave the best results was core number 3. And here, based on the foam percentage in the asphalt, we started checking the remnant stability to get the percentage of asphalt that we were going to use for remnant stability. And the other process that we needed to do in order to know how much asphalt we needed to have in our mix was injection time, to know how many grams of asphalt we were going to incorporate to the mix. In the first stage, that was the lab stage, we can get to the following conclusions. we incorporated more asphalt from 1.3 to 3.2 in sample number 3, and we molded cores with each percentage of asphalt to do all the tests that we wanted to conduct in the lab. We also took into account the maintain resilience to know what type of asphalt we needed to use. So in this case, the optimum percentage of asphalt to use was 2.9%. That was our conclusion. That was the first stage, which was the lab stage. Based on that, then after a few years, we tried to do a test run on a road where there were works. We got to a stretch that we could use as experimental with 3 characteristics. One was the original design of the road, and the second one with granular stabilization and foamed asphalt with a base that was covered with 2 layers of asphalt mix. One was 5 centimeters and the second one was 10 centimeters in thickness. What was used in this case was 73% of RAP. We added 10%, the soil that was 10% of fines. Soil was 15% and commercial lime was 2%, and the curve was within the limits of the manual. Here we can see the curve. At the bottom is with a contribution or more fines added and then more cores added. We needed to determine the life expectancy of the foam and the expansion rate. The first one was more viscose, more like CA10, temperature. One addition here, we did not use the simulator, but the whole analysis of asphalt foam was at the nozzle of the recycling machine in order to calculate expansion ratio. Temperature was 162 degrees, 6.5 bars, 2% of waters, 2.6% of asphalt, and the initial expansion was 24 centimeters, and final expansion was 1.7 centimeters. So expansion ratio was 14.1, and half shelf life of the foam was 15 seconds. We prepared Marshall cores with 75 impacts per side, and the density was between 199 and 2.03, and indirect traction was RTI of 6.0 kilograms per square centimeter. In the Marshall tests, we got stability that was 700 kilos. Remnant stability was 90%, which is above the 75% marked in the standard. Marshall fluency of 2.7, and to those probes we conducted all of the tests with a dynamic module with 2 different frequencies, 2 and 5 hertz with a load of 100 kilograms, and the modulus we obtained were 4600 and 4700 MPAs. That is for the Marshall probes that were taken to the lab. Here we can see the construction process that was used using lime, then the correction material, and then it was reclaimed. Then the asphalt truck incorporated water and virgin materials. Here we can see the on-site measurements of half-life of the foam and the expansion ratio and the depth of the reclaimed material to take the samples that were taken to the lab and do all the tests that we mentioned before. Once this was executed and once some time elapsed, around 6 months, we extracted cores in order to analyze the behavior of the base through the lab tests. Here on this page, we can see that the original work was or consisted on granular stabilization plus 180 millimeters of asphalt mix. In the experimental stretch, which was 100 meters, we had granular stabilization with RAP and foamed asphalt at 280 millimeters and an asphalt mix that was 100 millimeters. And the second stretch, in the manuals, you always found that on granular stabilization with asphalt foam, you could have 50 millimeters of asphalt mix, and that's what we did, but the granular stabilization was 330 millimeters to work in line with the geometry and not alter the parameters and specifications in the bid. Here we have the details of what I just explained. We had cores 1, 2, and 3, and the total thickness was comparable, but since the original granular stabilization was done with lime, it couldn't be extracted completely for test 1. In the other two, with the foam, we were able to extract the total thickness and have complete cores. We cut these cores in 3 sections, and compacting was in one of the stages of the total thickness to check whether there was good compaction and behavior in the whole thickness. As I said, we studied the top, medium, and bottom sections. The density was not altered, and it was maintained despite compaction. We had a density that went from 2 to 204. Indirect traction, that is one of the parameters that we evaluate for this indirect measurements, behaved very well. It was above 6, going from 6.2 in the bottom sample and 6.9 in the top sample. Stability was from 650 to 690, and the fluency was around 1900. The dynamic modules and the cores that were extracted in 2 and 5 hertz in the middle and top layers were similar to what we obtained in the lab tests under lab conditions, and in the bottom layer it was reduced because there's a decrease in compaction. But the important thing is that in the top and medium layers it would not be applied. Another important thing that was done was that at that point we did not have a deflector, and we used a Benkelman for deflections in the two areas with different thickness, and in the other one that was outside the test area. What we could see here is that both when we used lime granular stabilization and 18 centimeters of asphalt layer, the measurements for the surface were matching what happened with 5 centimeters of asphalt layer, and it was a little better. And when we had 5 more centimeters in the asphalt layer, deflections drop, but the curve radius are increased. The conclusion is that with this type of base, the contribution of new layers can be decreased substantially and obtain big savings. This comment is the explanation that I just gave you. We are coming to the end of our presentation, so based on that experience that we did experimentally, and now after 2 years, we conducted actual works in the province of Buenos Aires, where we did granular stabilization with foamed asphalt with an average width of thickness of 18 centimeters. What we found was in good condition, and on that we did 2 layers, one 5 centimeters plus 4 additional centimeters. So in whole, it was 9 centimeters thick. And now we are doing asphalt mix in one stretch, and the other one was the granular asphalt subrace, and this has been in use for a year. That is optimum. Unfortunately, because of the pandemic, we were not able to go on site and check the structural status of that base nowadays. This was the status when we found it. This was the condition. It was a problem of the top layer, and on the sides, in order to be able to use the foam, we use cement granular stabilization to do continuous foaming in the 7 meters. Here you have the process when we did foamed asphalt, and then at the bottom you can see the surface of the foamed asphalt, and on top of that we built the other 2 layers. The conclusions. Here what's important is that thanks to the experimental and lab stages, we were able to apply this to actual works on roads in the province of Buenos Aires, and we are planning 2 more. And really, the important thing here is to notice the good behavior of this type of base and the reduction of asphalt thickness. As soon as we have information about these new roads and these new projects that we're going to face in the future, we're going to give you more information. Thank you very much. Thank you, Pablo. Now we're going to give the floor to our next presenter.
The next presentation is about the Uruguayan experience in the rehabilitation of flexible pavements with foam asphalt. And the presenters are going to be Horacio García Terra and Lucio Borelli. García Terra is a civil engineer for over 20 years, has been the director and technical representative of Construcciones Viales and Civiles company, and Lucio Borelli is a civil engineer, and he worked both in the public administration in the National Road Association and the Transport Ministry, and he also worked at the private sector. I've been working for over 15 years in the private sector. So you have the floor. Thank you very much, Juan. First of all, good morning to the Americas and good afternoon for other regions. And first of all, we want to thank PIARC organization and specifically Engineer Jair, who gave us the opportunity of sharing our experience to the world. And let's start with our presentation. The experience in Uruguay started in 2016 in the Route 36. We rehabilitated several stretches in a highly deteriorated road. And in 2017-2018, we started also rehabilitation, and we had to stop during winter time because the foam asphalt technique must be applied with over 15 degrees centigrade. So we need to mention here that all these interventions were done following the South African technology, the one that is in the guideline for bituminous binder for foam asphalt. The stretch in Route 23 was 30 kilometers long, and we recycled the materials from the existing pavement, and the only new addition was the 4 centimeters overlay wearing surface. And then in 2018, we also rehabilitated Road 102, road that our company had already constructed 10 years ago, and the life cycle was at an end, and so we rehabilitated 2 roadways. Afterwards, we did a small stretch of rehabilitations of 2.5 kilometers in Road 33 in 2019. We are focused today on the 102 road stretch in 2018 with an AADT of 22,100 vehicles, and out of them 3,300 are trucks. So now I will give the floor to our resident engineer so he can give us some details about the implementation of this technique in this job. Good morning, everybody, and good afternoon to other regions. As Horacio already said, this road had been constructed 10 years ago and had 16 centimeters of mixture and 45 centimeters of granular material. When we had to do the recycling with foam asphalt, there was already crocodile skin, and we realized that when the road had to be recycled, some block could come off. This implied extra cost for the road administration. We were asked to do a test first of recycling with no milling, and we found out there were blocks already, and this is not desirable in this layer. So we were forced to do a pre-milling and pre-profiling and pre-compacting. Pre-profiling is very important because if there's a deficiency when you apply this foam asphalt together with the Portland cement, maybe under or over application of these materials. The cut planning is one of the most important tasks when you are going to recycle a road. But you need to take into account the symmetry of the recycling machine, because the right side recycles next to the roads and the other there's a half a meter mismatch. I don't want to enter into too many details about the planning of the cross-sectional cuts, but it depends on many factors. And in the case of Road 102, we did on the first day the slow-speed lane, laying the Portland cement without lapping, because it's very important, because it helps to distribute foam. But at least we need 15 centimeter lap between cuts, not lapping the Portland cement, but do a lap in the foam asphalt. As to longitudinal cuts, it is important to point out that we need to take into account the asphalt cement, and we cannot use up to the last drop of asphalt cement. We just loaded an asphalt machine with 20 or 30 tons, but we just used 27 tons of the asphalt, and that 27 tons pass resulted in 375 meters stretches that could be used during the morning. And it's important to try to avoid joints, because transfer joints mean that you need to uplift the machine and connect the asphalt mixer. And so South African people taught us a good trick. You do the first cut, and in those first 375 meters, you disconnect the water system, go back, connect everything again, and start with the second cut. 30 meters before getting to the first end, straight you close the nozzle of the foam, and you do the transition from one cut to the other, and 1 meter before positioning the machine, you once again turn on the foam nozzle with the mixture already done, and you avoid time wasting. It's important to pay attention to the checklist that comes with it at the beginning of the day. You need to follow the checklist, because this is going to avoid issues and problems. We need to check that water is coming out from the foam nozzle, and we need to check how the water and foam are coming out of the nozzles. At the beginning of the day, we connect the water hose that go through the whole truck. We have 25 centimeters of water hose, and when connecting the hose to the recycling machine, we have to check all the elements. Then we add the Portland cement to the already marked road. I don't know if you can see there, but we mark all the stretches, and this is very important to avoid lapping of the Portland cement and the 15 centimeters lap among cuts. 15 centimeters may seem a lot, but when you use it in a road, it's good, and you need to have a good guide wire system. Once we laid the Portland cement and we swept the Portland cement, and if you are not doing a lap, you are including 2%, and you may find out in time a transverse cracking. That's why you need to sweep. And then we hit the outlet of the asphalt truck hose, and we need to make sure that we take out the stopper there, the plug that is there. Once we remove the asphalt plug, we connect the asphalt hose to the recycler, and we do an air purge until we have a constant flow of foam through the central nozzle, and that's when we can start recycling. We can see a photo here of the recycling train with all the different machines. As I was saying before, Road 102 had 22,000 vehicles a day with a median and many vehicles, and we have to deviate all the traffic in order to work. When we start the day, we need to check with the infrared camera or to detect any obstructed nozzle, and we also need to monitor that the foam is okay in the front nozzle. There's a person always helping the machine driver, especially in the curves, to help to guide the truck driver for the lapping. We need to make sure that we go on the right lane, and we have a iron road to check that we are getting to the recycling thickness. And the lap side, what we need to monitor is that the machine is parallel to the floor, to the road. The control of the foam nozzle, the foam pump, should be over 3 bars to ensure good quality foam. If you suspect that a nozzle is not working properly, the machine has the order of feeding 2% asphalt, and this is 232 per minute. If you close one nozzle, the asphalt pressure should increase, because 232 kilos it's what you need. So this makes sure that the nozzle is working properly. We know that it has to be 232, and it's very important that the pressure is over 3 bars all the time. And this should be considered all the time. I'm not going to enter into lab details, but sample taken should include the whole recycling thickness. This is very important. As to compacting, the truck driver should choose the stretches for passing the compacting machine, maybe 7, 9, 8 passes. But in this case, the driver must choose up to what extent or what is the stretch to do the passes, and then to go back. And the driver needs to have a guide in order to be able to compact the whole thickness of the recycling stretch, and this is very important. We need to clean the roll of the truck there, because if not, it loses its property. Once this machine finished, we need to go to the next step. So we have foam, and we need to present it. We have the compacting with a plain roll to ensure that the joint has the right density. Then we have profiling and final compacting. Then we have You can see there the pictures during the whole recycling process and the different compacting stages. We need to take into account all the steps to follow. The important thing is not to lose moisture and wetness. As conclusion, then we have the slushing. The slushing is a saturation of the surface and high-speed tire passing to seal the stretch. We need to have a cross-sectional profile control because these prohibits over 5 centimeters overlaid. So we are going to place 4 or 5 centimeters of layers, and there's no deficiencies allowed here. We are talking about a highly abrasive materials, and we need to daily change the blades. We need to change blades every day and change them every 2 days. When you finish one stretch, you need to disconnect the water tank, and with this valve you closed this, and the recycling goes backwards, and you can see here the recycling machine going in the reverse direction. And 5 days later we realized that there were some issues and some things that were missing, and we had to do some things to solve this issue. And first of all, we need to close the water tank valve and the asphalt tank valve, and close the recycling valve and purge the pipeline. And those 25-30 liters will be dumped into a 200-liter drum. Then, when we end the day, it's important to clean all the nozzles in the recycling machine, and these have to be done outside the recycling stretch, because if not, we will be creating some issues in the recycling stretch. In the case of Road 102, we need to remove the excess material, and this excess material was removed from the place, and the remaining material that was on the curb. And then we need to do protection irrigation, and in the case of Road 102, it was exposed 2 months to traffic with those 22,000 vehicles a day. And this irrigation of 200 grams per square meter should be done twice by irrigating 1 liter of diluted solution. Then we did also 4 centimeters of traditional asphalt mixture, taking all the precautions required with this thickness. A very important logistic problem that is not taken into account many times is the consumption of water. A lot of water is consumed in compacting and in keeping the stretch wet, and it's really is an issue in many regions or places to get that amount of water. Also, the warming of the asphalt at 190 degrees centigrade when we have it at 150 degrees. So in order to have the tank or the mixer working at 180 degrees, we lose 10 degrees centigrades. 102 Road had a traffic counter that classified the axles, and so we could have the calculation of the equivalent axle number. So there were 1.6 million axles that went through this road, and there's no routing, though there are 5 traffic lights. You can see the current state of the pavement, and the only issue I found out is this cracking here that it just requires sealing. This, the IRI after 3 years is 1.5 meters per kilometer, though it's a very urban stretch with a lot of traffic. So thank you very much.
Bueno, acá les mostraremos un video que un poco resume y grafica todo lo que Lucio les ha hablado.
Here we can see a graphical presentation of what Lucio has described so far. These are images from Road 102. I would like to thank the London International, the South African colleagues who had helped us to apply this technique, a technique that they have been researching and working on for over 20 years. They have been doing research on the stabilized asphalt mixtures and foam mixture asphalt, and I would like to mention them because we are already friends after working for so many years. I would like to mention Professor Kim Jensen from Stellenbosch University, my colleagues from Road International, based in Durban, Andre Bailing from PBI Consulting, and Genera Jones, who also was involved in the mechanical design methods, where the foam base is part of the pavements. So I would like to thank you. You can see here on the video the kickstand work, the cuts, and the cut material is removed to avoid non-adhesion or detached material. Here we have the profiling and final compacting, and I would like to thank PIARC for the invitation to share our experience to the world. And I would like to tell you that we also have a project for next year. Route number 6 is a PPP project for the rehabilitation of 74 kilometers of road, and the whole project has been designed by ourselves with foam asphalt stabilized techniques in place. Thank you very much.
Horacio, Lucio, muchas gracias. Interesante trabajo.
Horacio and Lucio, thank you very much for that interesting presentation. And now we're going to move on to the last presentation called Organizing Asphalt, High Modified Binder with 50% Recycled Asphalt with Warm Mix Foam Technology. This presentation will be done by Nicolas Bueche from Switzerland. He's a civil engineer and he has a master's in airport pavements and a PhD in warm mixes. He's a professor of pavement infrastructure in the University of Applied Science in Bern. Nicolas, you have the floor.
Good afternoon. I assume you hear me. It's okay, I guess.
It's okay.
Okay, so I'm happy to speak. Thank you for the invitation. For me, it would be better to be in Argentina, but anyway, I have to do it from Switzerland. For you, it's soon lunchtime. For me, it's almost evening, but I will try to explain a bit our project dealing with high modulus asphalt with 40 to 50% recycled asphalt produced with a warm mix technology. Okay,
The slide are in French. I will explain in English. I think it's easier. Most of you speak English. I will briefly introduce the topic. Then we'll explain you in more detail the project I want to speak about, and then some conclusion. Just at the beginning, just that we have all the same understanding. Explain briefly what I mean by recycle aggregates, by warm mix asphalt, and by high modulus asphalt. This is just that we all have the same understanding, and then we'll go deeper in the project. So recycling aggregate or RAP, I think everybody knows more or less what it is. It's an old pavement that have been recycled. For sure, it's very interesting. What is interesting? It's a Swiss perspective, let's say, but if we take a RAP, there is approximately, let's say, 5% of binder, but this 5% of binder has a very high value. Talking about price, if you pay, let's say, $100 Swiss franc 1 ton of asphalt, in our case, the bitumen will cost approximately 40%. So the value of the bitumen in this RAP is very, very important. That's why we try to reuse as much as possible. And we also call it the same as you claim asphalt pavement. So this is a table that you can find that we have in our Swiss standards. It's basically in the table, we have two ways of including RAP. Cold mix, so in cold addition, or in hot addition. Usually we do only hot addition of RAP. This means approximately 120 degrees in the plant. And speaking about high modulus asphalt, what we're gonna add here, according to the current standards, it's up to 30% RAP in high modulus asphalt. You can see for top layer with very high solicitation, we won't have that much RAP, but for the lower layers, we can go up to 60 or 70% RAP in asphalt mixture. But what concerns topic for today, for high modulus asphalt AMA, we want, according to the standard, we can go up to 30% reclaimed asphalt. Now, just explain briefly what we call by AMA, so high modulus asphalt, enrobé à module élevé. As everybody knows, Switzerland is a small country, so our strategy is, let's say, quite simple. We try to look what the French guy are doing, try to look what the German guy are doing, and then we just pick what is interesting for us. And that's what we did basically with the AMA, the high modulus asphalt. It has been initially developed in France in the 80s, if I'm correct. There is two types. Type C1, which is a high rutting resistance, and type C2, which is high fatigue resistance. We used to have in our country a research project where, let's say, we define a bearing capacity coefficient for high modulus asphalt. And basically what you have to understand here is high modulus asphalt is the product which will have, let's say, high stiffness, high rutting resistance, high fatigue resistance. It's a, let's say, top product that we're gonna use mainly on the highways. Just going back a bit to the standard to explain you, as I told you, we have like two types, the C1 and C2. Basically, high modulus asphalt, we need a very low penetration binder, 1020 or 1525. And what is interesting, I can show you here, first, we have this water sensitivity aspect, ITSR ratio, which to my perspective is a bit a joke because we have a limit value of 70%. This we can reach, let's say, quite easily. But what is interesting, we have rutting resistance, French rutting sensor, so maximum 5 or 7.5%. We need a high stiffness, 11 or 14,000 megapascal, and very high fatigue properties, which is a bit a tricky point. Working with high modulus asphalt, you have to, on one hand, to get high stiffness, but on the other hand, to have a good fatigue properties, fatigue performances. And what you can find in this table is basically a summary of what we have in our, let's say, national standards. Now we spoke about RAP, we spoke about high modulus asphalt. What we mean by warm mix asphalt, I think it's worthwhile just to briefly define it because I have seen in some country warm mix asphalt which were, to my perspective, quite hot. So what we call in Switzerland or in warm mix asphalt will be an asphalt mixture which is produced at approximately 120, so produced and laid at approximately 120, 130 degree maximum. Normal mixture will be produced at 160. Here we want to produce and lay the asphalt at 120 degrees. We have different products, different ways to do it, but most of the plants are working in Switzerland with the foaming technology. As some of you know, Switzerland is a, let's say, Hamad country. Hamad is a very important plant producer, and most of our plants are working with the Aman foaming system, foaming technology, which is with one bitumen plus bitumen foaming. So the technologies that have been applied in the framework of our projects of really foaming technology of warm mix produced at 125, 120 degrees. Now I come to our project. To make things clear, it's not my project. It's a project that has been initiated by our National Road Administration, where there were a lot of actors, private labs, consultants, etc. I was lucky enough to be part of the project to make the summarizing report, some of the coordination, but you have to see this more as a group work and it's not my own work. I will explain you briefly the motivation and some results that we get. Motivation is quite easy, let's say. For National Road Administration, we work using high modulus asphalt. So you have a top layer, then we have 2 layers of high modulus asphalt, which is, okay, at the national level, we use it quite a lot. And we now, as everybody, we have this sustainability issue, and we believe that we have to bring a substantial contribution to the energy and environmental aspects. And that's why the National Road Administration say, okay, we want to produce this high modulus asphalt in a warm mix perspective, but adding a high percentage of reclaimed asphalt, which is a bit tricky. So we have high modulus plus warm mix plus a high wrap content. And the figure you can see on the right hand side is just where, if you can see this curve here, the 50% wrap, it's a foaming technology. And if we take the same mixture without wrap, it will be, in that case, the yellow curve, which demonstrates that adding wrap is not always negative. In that case, it was a specific test. By adding wrap, we get even less rutting for the asphalt. Coming back to the project, as I told you, it's a pilot project in the region of Sangallan, which is on the east part of Switzerland. The idea from the Federal Road Administration to go beyond the standards. We want to have more reclaimed asphalt than what we can find currently in the standard, and to combine it with the warm mix technology and recycling technology. If we look at the pavement structure, this is what you can have here in the table. So we have a top layer, which is, let's say, classical low noise asphalt top layer, 30 millimeters. We call it semi-dense asphalt, but let's say it's low noise asphalt. And then we have 2 layers of high modulus asphalt, C1 and C2, 80 millimeters for each layer, and with 50 and 40% wrap. If you remind, just a quick reminder, we say in the current standard, it's up to 30% reclaimed asphalt. With this project, we go to 40 and 50% reclaimed asphalt content. Production temperature, 115 to 120 degree, compaction temperature between 105 and 115 degree. All the asphalt has been laid using machine, so nothing just by hand, just with the machine. And which is important also that we use the same recipe. So the same recipe for the reference hot and warm mix asphalt. So there is no, let's say, mixture optimization. So important, we made these 2 layers with warm mix with 50 and 40% reclaimed asphalt. This is just a general table to show you that we made quite an extensive laboratory testing phase. We analyzed bitumen, bitumen delivery, recovered bitumen, analysis of binder, analysis of the asphalt, low temperature, high temperature behavior, stiffness, rutting, etc. I won't speak about every test results, otherwise you will be a bit late for your lunch. We just pick some specific topics. Let's say, explain a bit what we get to the stiffness value, fatigue properties, rutting resistance, water sensitivity. Just, let's say, a short summary. If you need some more information, please just ask. I will just briefly explain some results on the asphalt mixture scale and also on the binder scale. I think as most of the countries, let's say Switzerland, we are for bitumen, pen and ring ball oriented. And let's say we need, at the beginning, we made anyway from test pen and ring ball. This is what you can see here. This is the pen test. On the graph, every index correspond to warm mix. So it's mean on the left hand side you have the hot mix, then you have the warm mix for a C1, and then you have the dark blue is the hot mix, and the light blue is the warm mix. If we consider the pen or the ring and ball value, we didn't see that much difference. We have a bit lower value for the ring and ball value for the warm mix, which is, let's say, quite logical if you consider the aging of the asphalt, but not that much difference. What is interesting for us, because I think most of the countries are also, let's say, pen ring and ball oriented, and we believe in Switzerland or at many other countries, I guess it's now going with higher wrap content, going with warm mix, with more complicated asphalt mixture. Pen and ring and ball is not sufficient anymore. We need to go on with other tests, with more specialized tests. And here, based only on this test, we cannot make that much difference. That's why what we did in the second phase, we go on with some DSR, some dynamic shear rheometer testing. A very short summary. Using the DSR, we'll analyze the rheological behavior of asphalt. So you will pour a very small quantity of asphalt, and you will have a shear loading with a given frequency, sinusoidal loading, and then we can see the behavior of the binder in that case. So we made some extensive tests using dynamic shear rheometer, and this is what you can see here for the C1 mixture. Do not forget it's a logarithmic scale, so the very small difference on the graph can be basically quite big difference in the asphalt mixture scale. So in the binder scale, sorry, and we could see, for instance, that the hot mix has a bit higher stiffness than the warm mix, which is, let's say, quite logical, once again, considering the aging, and also that the warm mix has a bit higher phase angle than the hot mix alternatives. If we do the same for the C2, this is the other high modulus asphalt, we can see some similar trends, meaning that the hot mix has a bit higher stiffness than the warm mix, and the warm mix has a bit higher phase angle than the hot mix, which is quite logical, once again, if we consider this aging issue of the binder. We also made some other tests. We made some multiple stress creep recovery tests. That's basically a way to assess, let's say, the rutting susceptibility of the binder. So we do it still using a DSR method, and the principle is, let's say, quite easy. We have some loading and unloading phases, and we will measure the deformation, the recovered deformation, and the remaining deformation of the binder. By using this, we could see some difference between the warm mix, which are the dark bars, the hot mix and the warm mix, and which was for us quite surprising that we have a better behavior for the hot mix than for the warm mix, and it was quite interesting to see this, which to be related to the fact if we consider the AMA, the high modulus asphalt mixture. Usually we always say when I had wrap is a hard binder. In the case of high modulus asphalt, we have to keep in mind we work with very hard binder. It's a 1020 or 1525. This means the binder coming from the wrap either is a high penetration binder, so a softer binder. So the binder from the wrap is a softer binder in the case of high modulus asphalt, while usually we always say the binder coming from the wrap is a hard binder. This is maybe just valid for a Swiss scale. Let's say in our country, most of the claim asphalt pavement will have a penetration between, I would say, 22 and 30. Okay, this is the rest of the test for the multiple stress creep recovery tests, where we could really see some difference between warm and hot mix asphalt. And then we made some more classical tests as well. There is no, let's say, Marshall limit value for let's say high modulus asphalt. This because visually we do rutting, stiffness, etc. But anyway, we did the test because it's a test where we can have some experience value, we can make some comparison. And here you could see, for instance, if you just consider the Marshall stability was higher with the hot mix asphalt than for the warm mix, and this for both the C1 and for the C2. And this was, let's say, quite interesting. Even this is something that we could expect. Once again, based on aging aspects. The water sensitivity, we do the ITSR. So basically, you have 4 Marshall samples. 4 will be conditioned in water. 4 will be in air, and then we make the Marshall test. And then we compare. We do the indirect tensile stress test, and then we will compare the value. And basically, we have to reach target value of 70%. We can see for every asphalt mixture, so hot and warm, we get ITSR ratio, which are, let's say, between 91 and 96%, which is quite good. Based on this, we can say we didn't have any specific issue related to water sensitivity of the hot or warm mixed asphalt. More interesting, the rutting tests. What we do in Switzerland, this is a French rutting tester. So we do slabs that will be tested, as you can see in the picture on the right-hand side. And we have a limit value of 5% rutting, so it's proportional to the slab thickness. Slab thickness is 10 centimeters, and the limit value of 5%. And you can see that both asphalt mixture, the warm mix on the right-hand side and the hot mix, are much below the limit values. It means that we do not have any rutting susceptibility issue, this for the hot or the warm mix asphalt. And then finally, we did some stiffness and fatigue testing. We used to work in our standard, we work with a trapezoidal test. I guess you know the trapezoidal test, literally for the stiffness and fatigue. It's a test which is quite good, but quite complicated to do. What is interesting here, if we consider the stiffness value, for the C1, we have a target value of 11,000 megapascal at 15 degree 10 hertz. For C2 of 40,000 megapascal, 15 degree 10 hertz. And we could see that for both asphalt mixture, we could reach the limit value, we can reach the target value related to the stiffness. And the same for the fatigue, and we are above the limit value of 100 or 130 microdeformation. This means for high modulus asphalt, warm or hot with a high dosage of reclaimed asphalt, we can meet the target value of stiffness and fatigue test, which for us was quite interesting. I think it was let's say a bit tricky. We had to do one trial for one of the mixture. It didn't work directly, but then it was okay, and they managed to do it. And all this material has been used for highway construction without any specific problem. So just a short summary also from a more practical experience from the laying company. What we could observe, let's say, first for the recipe, we needed 1 or 2 iterations just to make sure that, let's say, the tricky point was really the fatigue and stiffness, that we can meet both criteria at the same time. Then a very important control point, the humidity, the water content of your asphalt mixture. It's a very simple measurement, but we will say, okay, when we do it, we have to control the water content of the asphalt mixture at the job site. If you have too much water, then you will have problem. Here we got like 0.04%. It was okay. The forming process was okay. The compaction was also interesting, and this has been measured also by the company, construction company. Basically, for the compaction energy, the company need one more compaction vehicle to make sure we get a sufficient density and the needed void content. To the compaction, in the case of warm mix, for that case, we need a bit more energy in situ or so to ensure we have the right compaction degree. The last point is also a bit, it's tricky, maybe it's more related to the Swiss case. We have a lot of batch plants, and so if we produce warm mix in the batch plant with a high RAP content, we have some, let's say, risk of clogging in the asphalt plant, which might create some problems. So we have to really always to be careful with the humidity aspect also in the asphalt plants. Now I come up to some conclusion, some perspective. Once again, it's only a Swiss perspective. We are a very small country, so I cannot say that what we do can be applicable to every country. But I think the first one, which is really important, in the project, we could demonstrate that we can produce high modulus asphalt, so with very high stiffness, good fatigue resistance, including 40 or 50% RAP, and produce it in a warm mix process without major problem. This can be done. This is no problem, and we could do it in the framework of this project, and we could, let's say, demonstrate the feasibility. As I told you, the aspect of RAP in high modulus asphalt is a bit tricky because the binder from the RAP is a soft component and not the hard component in that case. From a general point of view, for the lab test, we get, let's say, rather coherent and consistent tests, and we could also, this is already known, but we could see that there's a very simple test that pen and ring and ball are not always sufficient. We need some more testing, more precise tests. from I think the next point of perspective, what we would like to do in future, or in Switzerland, what I hope we can do in future, is really to go in a way that we can optimize the mechanical performances of such mixture. We do not have, let's say, a real Swiss mix design method. We are rather at the Stone Age in that field. That's why I think this is something we can really improve also with a better mix design method, and also improve the mechanical performances of such mixtures. Finally, about wall mix and recycling, it's coming from one hand from the politician, so all the people, the stakeholder, they wanted to increase the RAP dosage is a different mixture, and this is, I think, right now in our country is the first priority. We want to do more recycling, and in parallel to this, we want to decrease the temperature. So we want to promote warm mix, cold mix asphalt, etc. And there are two very important trends in our country. The question is raised, how can we do it? Okay, to do it, first we can make more experiences, more projects like this one. We can also have an impact on the standards at a national level, because at a European level, okay, we can always make a contribution. We are not alone. We are only a small Switzerland. And so now we try to develop some best practice guideline. The book that you can see on the right-hand side, it's a best practice guideline that our university just published in the framework of a project initiated by the Zurich region. Basically, it's only a best practice guideline, very practical oriented, which explain how can we do in order to use more RAP and to promote warm mix asphalt. With this, I'm now at the end. It was very short. Anyway, I hope you enjoy, and if you have any question, you can contact me. You have my email address, phone, everything, and thank you very much for your attention.
Thank you very much, Nicolas. Pasamos entonces ahora.
So now we go to the Q&A part of this panel. Questions by our audience. I start with one question for Nicolas.
And it's would the increased stiffness of the EME high modulus asphalt affect the low temperature cracking performance?
Yes, it is true that if we work with high modulus asphalt, we used to have some low temperature issue. I think that this is normal because the stiffness is much higher. The first thing that we used to say here that the asphalt, so the high modulus asphalt, should be covered directly. We cannot, let's say, wait 6 months before to put a top layer. This is a first measure, something that we have to do if we want to improve this aspect. And the second thing that we are some project where we try to work with modified asphalt binders. So always, let's say, hard binder, but with PMB, with SBS, etc., to improve this low temperature behavior. But it is true that the low temperature behavior can be an issue, but this is something that we can handle in.
Thank you. Una pregunta para...
A question for our colleagues from Uruguay. Which was the equipment used in the process? And can you give us an idea of the yield per day or performance per day and the crew? The equipment was WR240. The performance per day is 2 tanks of 27 tons. So it's 54 tons, 1,500 meters per day, and the whole job was 6.5 kilometers, 2 lanes, and it was done in 6 months. Of course, it depends on the recycling thickness and the amount of asphalt that you are going to add to the recycling material, but with 2 trucks, with 2 tanks, it's enough with a standard crew. In our case, that stretch shown was 25 centimeters of a stabilized base, compacted base, and it was BSM 2. It was not the highest quality, but an intermediate quality material. Thank you. I have another question for you. What's the minimum recommended temperature, the minimum recommended ambient temperature for laying the foam asphalt? Would you just have to check that the material temperature at outlet of the recycling machine is over 15 degrees? If you have this, it's okay. Question for our colleagues from Argentina. What was the criteria used to decide when to put the overlay on the stabilized foam asphalt? What was the criteria used to decide when to lay the surface on the stabilized base with the foam asphalt? There's no time. You can just lay it immediately, because once you finish the compacting of the foam asphalt and the ceiling, it can be open to traffic, so you could lay the next day the wearing surface. At the time, we placed the wearing surface 38 hours later in our testing stretch. I have some similar questions for the Argentine and Uruguayan presentations. The question is, did you do deflectometry tests in the foam test? Did you DFW? I think that the Argentine colleagues did not do them, and in Uruguay, the National Road Administration in Uruguay may measure the deflections with the DWW, and they use 800 megapascals for the layer. This was done 6 months after, and I think that the National Road Administration would request a test again, because we have finished the job 3 years ago, and so with as Lucio said, these stabilized layers with the foam asphalt and with emulsion also had an increase in modulus over time as a result of the additional densification. The failure mode of these layers is rotting and not aging, because they are not fully bonded layers, so they behave as a granular layer where the binder is providing cohesion qualities and waterproof qualities. If there's a failure in the wearing surface, the base would not be affected or eroded. Thank you very much.
For you is what type of plants do you recommend for 50% of RAP recycling?
So, as I do not sell plant, I cannot really recommend the plant, but no, I would say work with Swiss companies. No, so what we have in Switzerland, we have batch plants. So basically, we only have batch plants, and we use what's so-called parallel drum. And up to 50%, there is, let's say, the first generation of parallel drum that can do up to 60% wrap addition. Otherwise, what we have quite a lot of plant in Switzerland, so it's a so-called 100% RA. For instance, for Ahmed, some other plant producers are doing this, but I would say parallel drum, this is the most important thing.
Thanks. For you, Nicolas, but it's in French and it's something difficult to me to.
Oh, and I don't see the question.
I will try to translate.
Yeah.
Somebody is asking you if you have experience of the influence of the agents you used for the most type of recycle.
Agents.
Tensioactives.
Sorry?
The tensioactive agents.
Tensioactive agents. Yes, we do have some experience, but let's say it's more, let's say, try and fail process. So I think some companies or retry with some specific product or some other. Basically, so far I think up to 40 or 50% wrap, we can still work using, let's say, only bitumen. Then going with a higher wrap content, we have to think about specific agent, rejuvenator, specific tensioactive, etc. So we do have some experience in some other project, but for this project, we just use, let's say, normal bitumen, no specific tensioactive in the framework of this project.
Thanks. Una pregunta para.
A question for Horacio García Terra. The foam recycle can replace the soil cement recycling. We have been doing both over the last 5 years, many kilometers, both with cement and with foam asphalt, 52 kilometers foam asphalt, and over the last 3 years, and I think that we have almost 150 recyclings with cement. So they are two different things, and each one has its specific application. For example, in flexible payments, I will be more on the side flexible payments, high volume of vehicles. I will be more on the side of foam-based payments, because if I have to do 20-year maintenance on that road, I would provide a higher life cycle for that road, because all of us know that cement stabilized bases tend to have fatigue failure, and we need to reconstruct them. I would like to add that for foam asphalt, you need to have a granular structure. I did not mention design and lab work, but you need to have not just cohesion that is provided by foam, but also the internal deflection angle of the material. And if you say soil cement in Argentina, I'm imagining extremely fine soils with very low coarse material, but here in the case of road 102, it was SM2. It's not the best quality because the deflection angle was below 40 degrees. So in case of foam, you need to have a good deflection angle. A question for you, also for you, about the future use of plant foam recycling, or foam recycling in plant instead of in place, and what you think about it. In place or in plant, you need to see what's the quality of the materials you have in place to decide whether the best measure should be doing it in place or go for an implant. When materials in-place materials or on-site materials are not the best one, you need to add some correction that would correct granulometry and what Lucio said before, internal friction of the material. And so in that case, you can reclaim the wrap, you can take it to the plant, you can add some correction, and then the material comes back ready to be laid and compacted. So in that case, we should go for the plant. And then we need to see whether it's a new job, a new work, or it's an existing payment where the existing material is a good quality material, and so on in place recycling is much less expensive because we are not going to have a material transport and a lower carbon footprint. Also, we need to compare quality with performance. If you are recycling in place on site, it's what you have there. But if you go in plant, you have different options. You are also limited by the tons and hours. It's a comparison between yield and performance and quality. And both have pros and cons. And the equipment to be used as KAM 220 in the case of the plants. Thank you.
What is the maximum humidity of the aggregates for producing warm mix with wrap?
Well, I think for the humidity of the aggregate, I think this is up to you anyway. You will have to dry the aggregates. Usually, I think our aggregates are, let's say, between 2 or 3% humidity. But to my perspective, what is really important, the starting humidity is important for you as a producer because it will cost you a lot to dry the aggregates. But more important, let's say the final humidity of the product. If you are working with foaming technology, just check the humidity of the final asphalt mixture. If the final asphalt mixture is too humid, then you might have some mechanical issue, mechanical performances. And this is, for me, the tricky point.
Thanks. Another for you is, how was the preheating of the wrap in the lab?
So this is it has been only plant produced, and they heat the wrap at approximately 120, 125 degrees. If we do it in the lab, we do it in a similar process. It means we will heat the wrap up 120, 125 degrees Celsius.
Thank you. Para los colegas de Uruguay, el espumado, ¿cuánto tiempo de...
For the Uruguay colleagues, how long is the cure time for the spoon? For the foam asphalt, it requires a couple of weeks curing time for the evaporation of the water required for compacting. Compacting is very important. It's critical. So the higher the initial compacting, the longer the duration of that layer and the longer the life cycle of the pavement would be, because these pavements have deformation failures and not fatigue failures. A question for our colleagues from Argentina. Are you using in Argentina any modifier to increase the life cycle of the foam? And if so, what has been the results and what type of modifiers you are using? For foam asphalts, we're not using modifiers so far. In the next jobs, perhaps we would use some modifiers, but so far we have not used them. Another question for you. What type of asphalt did you use in the foaming? I think I mentioned that on the presentation. It was 70-100 asphalt. but I remember that viscosity was approximately 110, 1 CA10, maybe CA10 or CA20. It wasn't the limit, but mainly CA10. At that time was called 1700. It would be 100 and 110 asphalt. 70/10, 100, sorry. So we are already run out. We have already run out of time. So I really like to thank you for your presentation.
Thank you very much for your participation.
Gracias.
Y los esperamos.
And we just remind to you that tomorrow we have our final day. Thank you very much. See you tomorrow. Thank you, everybody.